Okay, welcome back. We want to understand from the last one that all we could do by solving when dy dx was 0 was to get these pesky x values, and we could then put them back into the original the function to find out what the coordinates were. But there's now that's not much of a picture, is it? That's really not much of a picture in terms of defining. Well, we haven't sketched much of a curve. All we've done is draw a bunch of tangents at points. And you're exactly right. That's all we've done. So we want to understand the nature of those turning points. We want to understand what happens at that particular point before the curve and what happens after the curve. What about down here? Is it coming from underneath the x-axis or is it coming from above? We know from the picture that I've drawn what's happening, but we need a better understanding of how we're going to pull that together. So having all these points is wonderful, but the fact remains that we've got to have some skills in assessing and understanding what's happening before and after those particular points. Okay, so we'll explore that now. So let's have a think a bit more. With this, what we did was assign it to 0. Solving it meant that we got a whole bunch of x coordinates. That meant there were just those flat lines. We haven't done anything else. All right. What about dy dx from the point of view of dy dx from the point of view of some other value that's not 0? So what does it mean when dy dx is 0? It means that it gives us a flat part. Now, all the way along this semester, what I've done is I've indicated to you that if you were to tell me what differential calculus was about, that I would expect you to draw a bunch of these things, okay? And they would all be indicators of your knowledge of differential calculus. But we want to be more formal. We've been doing that informally for a few weeks and having a bit of fun, even when we studied linear. But now we want to formalise that somewhat. Okay, so let's think about what happens in a particular scenario where we have a curve that's changing and that it has a maximum and it has a minimum. So it's not cutting any of the axis, so we're not particularly worried about that. All right, but we're interested in this function from the point of view of what's happening before and after, because when we assign dy dx equals 0 or y dash equals 0, we get those x values, don't we? So we get those x values. So they're particular turning points. So that's x represents a maximum, we think. We haven't really bothered too much with that, but we'll do some more on that. So this x represents a local minimum. So I've kind of expressed that in the previous slide where we talked about local max and local min. But I want to know what happens on the way towards this particular graph. Now, is there a possible way of interpreting what's happening with the gradient? Well, one of the things that I asked you to do when you had a particular function was to think about doing little linears. And the little linears are just that, little dominoes or matchsticks. And what they're doing is they're showing the nature of the gradient at different points. Now, how do we formalise that? How would we reconcile that? Well, we can use our classic equation, can't we? We can find values of derivative, and we've got to consider our gradient. So f dash of x would be our function value plus some value of h. Remember this? And some other value of x. And what have I left out? The insurance policy. That's right. So we better put the insurance policy in because that's the one that says there's a limit. We need to have this quotient protected from h becoming the denominator becoming 0. So we do that with the insurance policy. So f dash of x is equal to this. Now, what happens as h gets smaller and smaller and smaller at a particular point? We're going to get values say this value of x here, we're going to get values that give us a tangent like this. So what that's going to show us is that our value would be greater than 1. Okay, greater than 1, but more importantly, greater than 0. So when the derivative is greater than 0, we're on the up. We're going up like this. So in this case here, we can say when the derivative y dash is positive, that's how we would say that, f of x, I don't really need to put this then in, but I'm going to anyway, f of x, the curve is increasing at that x value. Increasing at the x value. And that's the value that we used here. Okay, so the x value. So we can say the curve is increasing. So derivative tells us quite a bit about the curve even after we did this other stuff. So this other stuff was f dash of x equals 0. Here f dash of x is equal to some value. What happens when it's positive or negative? Okay, so in particular, what happens is that we join together now our interval knowledge, and our interval knowledge tells us that for this particular function, f of x is increasing for all of the x value below. So they started off and came, f of x is increasing. Okay, f of x is increasing. Now it happens again. So there's two values where it's increasing. Okay, for all the x values that go this way, look, f of x is increasing. There it is. The derivative at those x values is positive and greater than 0. So there's two locations in this graph where f dash of x is positive. So what about when f dash of x is negative? Can it be negative? Well, here we are. We're doing the formal speak, aren't we? We're doing the formal speak. So we'll go for a green one, and we'll say the same thing this time. We're going to check at some particular x value. We've got our insurance policy in play. We've got h becoming smaller and smaller and smaller. And then we have our function value that is being modified by h and showing us the rise. And it's doing it in a very clever way. So it's showing us the rise over the run, and that gives us the rise over the run at a particular point. Now, if we go ahead and have a look at these little increments here, oh, look at what's happening. Our formal computations at some value x are giving us decreasing values. So there's our x. There's a tangent going off there. And that is less than 0 or negative. The m value is less than or negative. So we can say that when the derivative is negative, because that's the math speak I've taught you to use, that means, I know it says less than 0 using symbols, but it also means negative. When y dash is negative, then in that particular location, the function is what? Decreasing at that value of x. So it's decreasing at that value of x. That particular value that we checked. Okay, it's decreasing of x. So that's the value that we checked at that particular location. Okay, so we've got now in here, in this interval, so this is now a closed interval, and we've seen this from our studies of intervals, that the curve is decreasing. So in this interval, we've got, I'll go back to the neutral colour. Actually, I might just change that to the colour red, just to match what I've been doing. So that one there goes off towards x positive infinity, that goes off towards x negative infinity. Okay, and then I'll go back to our neutral colour, and then we can say the function is increasing. Here the function is decreasing, dec for short, and increasing. So it's increasing at different values, and all we're doing is having a look at the derivative and asking the formal nature of is it plus or minus. Okay? So what we find is that we can use derivative for non-zero values, and that tells us about the nature of the curve. Non-zero values tell us where the curve is increasing or decreasing. And I want to use a more formal language there, where the curve is increasing or decreasing. So increasing or decreasing. And they're occurring in intervals. So these are our formal ideas here. We can mark the values and we can find them, and then we can put together an interval where the curve is decreasing and where it is increasing. So this delivery of where a curve is decreasing and increasing using an interval is going to be tested, if you haven't already seen it, in the work that you're doing on Pearson. Okay, so it'll clearly want you to be able to identify when it's increasing and when it's decreasing. So I want to go back to curve sketching because I think we need to readdress this business here. We haven't really finished over here, have we? We've kind of got our m equals zeros, but what about, do we have to check y dash in x values just beforehand? Well, that would tell us if it's increasing or decreasing. Afterwards, it would tell us if it's increasing or decreasing. So we could do an interval check. Okay, we could check the value of the derivative in some value, and all we would need to do is put in our value, f dash of x. There's our function notation. Okay, so put the x values in there. Okay, and we would test that. Now, if the result was positive or negative, we could likewise do the same thing here. We could test our derivative with the x values from here somewhere, and that would tell us, is it positive or negative? And likewise, we can test our derivative here and put the x value in, and is it positive or negative? So increasing, decreasing, increasing. So that's what Pearson's going to be asking you to do. So we have to find those values. And that's fairly straightforward because we've got the location of them here. These are our location points here. We've got our coordinate pairs. All of our coordinate pairs are giving up all of these points here. So they have an xy value, and all of those points are going to help us to understand what happens next. Okay, so we get all of those values, and we've got x and y values. So instead of testing before and after, which we can do, we can use those as the interval segments. Those locations represent the interval segments. All right, the next thing I want to do is think about a different approach to deciding what's happening before and after these m equals 0. I want to go back and see if there's another approach, and it turns out that there is. So there's another step, an alternative step to this particular testing that we can do to help us understand what's happening to complete this graph. Okay, now I haven't put any numbers in here deliberately because I just want you to think about the concepts of increasing and decreasing. All right, I think we'll have a go at that in the next video. I'll see you soon.